There's a group of participants that are involved in this idea of creating valet keys that we're going to hand out for the web. So let's look at what those participants are if we're going to use OAuth for doing mobile authentication. And when I say OAuth, I mean OAuth 2.0, although I'm going to be saying OAuth over and over. The first one is the resource server. And this is the entity that is responsible for managing all of the resources, the bits of information or the services that we would like to be able to control access to using OAuth. So this is going to be like your Spring controllers, the data stored in your database. All of these things are going to be part of the resource server. So this is really your application that you're writing, your Spring-based application or cloud service that you're writing. You can think of as the resource server. The second piece of this is the authorization server. And this is the server that is going to be responsible for deciding who should get access to what and managing and brokering those types of interactions. And although the word server is used here, these things can be combined into a single application. So for example, when we use Spring OAuth, Spring provides a controller that plays the role of the authorization server. So even though it's a controller and all of our controllers are also running in the same application, it's still called the authorization server. And then we have the resource server. And then we have the client that is going to be trying to get access to some particular resource. And then finally, we have the resource owner, which you can think of as our users. So we're going to also say that this is a user. So when the client wants to go and get access to some resource, what it's going to do is it needs to get a valet key to give it access to that particular resource. So what the client does is it will go and ask, using one of the OAuth flows, for the authorization server to give it a valet key. Or in this case, what we're going to talk about as valet keys are tokens. So it's going to do something like send a request to /OAuth/token, asking for a particular token that it needs. Now, depending on the particular OAuth flow we're using, if the client already has the username and password for the resource owner, or in this case, the user in our system, the authorization server can go and validate that information and create the token that it needs. In the case that we're going to be working on, we're going to be using, because we're building a client for our own service in the cloud, and we control the implementation of that client and we trust it, we're going to be using a password grant where we're going to actually provide the login screen that allows the resource owner or user to give their username and password so that the client can go and get a token or a valet key. However, if we were using one of the other flows, what would happen is that the authorization server would send a request back to the resource owner. Typically, this is displaying a login page to the resource owner. The resource owner would log in, and then the authorization server would give it another page saying, this client wants access to X, Y, and Z capabilities in your account. Are you okay with that? And you would say yes or no, and then the authorization server, depending on what you said, would either give the client a token or not give it a token. Now, in the flow that we're talking about, we're going to be using a password grant. So the user is actually going to provide their username and password to the client, because we're building the client and we're building the service, so we trust our particular client. So the username and password is going to be provided to the client. The client is going to do what's called a password grant. It's going to send a post request to the authorization server, and in Spring, this post request is going to go to /OAuth/token. And inside of this post request, there is going to be a request body that is the URL encoded key value pairs for the username, the password. So these are the values that were provided by the user or resource owner. the client ID, so in this case, an identifier of our client. We're also going to have grant type, and that's going to be equal to password. And then finally, if we want to, we can have scopes, which is we can ask for a specific set of resources that we would like to have access to. So this is similar in many respects to the roles that we talked about with Spring Security. This is asking for a scope to have access to on the resource server, and that will determine what this valet key is good for or not good for. So the scope is determining, is this a valet key that will turn the car on and allow me to park it? Will it allow me to lock the doors? Will it allow me to open the trunk? Will it allow me to open the glove compartment? That's what the scope controls, is the scope of access. So all of this will be sent to the authorization server, and this will be URL encoded into the body of the request. Now also in this, Spring requires, with its implementation of this flow, that the client authenticate itself. So HTTP basic authentication is going to be used for the client and the client's password. So this is for client. Now, the idea behind this is that we could have a client that we trust more or less than another client. And so on the server, we could store secrets that were associated with specific clients. So a client could prove its identity by providing its ID and its secret. Now in this case, the client that we're going to be installing on the mobile device is sort of out of our control. It's going onto infrastructure that we don't control. And so if we embedded a secret into this client, anybody could decompile our app and simply take that secret out. So it doesn't make sense in this case to actually have a client secret and authenticate the client. So in our case, we're actually just going to be using HTTP basic with an empty password. We're not going to actually be assigning a password. The only reason we're doing this is Spring actually requires that we use basic authentication for the client as part of this flow, because it is in the OAuth spec. But in this case, we can't have a secret and have it protected on the client. So we are not going to provide a secret. We're just going to have an empty password for the client. Now, this may seem like scary, like why are we using an empty password? Doesn't that mean anyone can get access? And the answer is no. Anybody, they still have to have a valid username and password, and the token or the valet key that we're going to be creating is still bound to this person's account. So we're just not able to prove that a client is a specific client. But we are using this flow because this is the one that makes sense when you write both the client and the server side of this stuff. What's going to happen is the authorization server will then look at all of the information that's been provided to it, and if all of it matches up to its expectations, so the username and password is right, and the HTTP basic is there, and we have all of the other parameters that we need, then it's going to return a token back to the client. And this token is simply a string that the client will be able to use in a second when we talk about the next part of access to prove that it has authenticated. And when it provides this token back to the authorization server will allow the client to get access to the specific resources that fall within the scope of the token that it got and the user account of that particular resource owner. HTTP basic is an authorization mechanism or authentication mechanism that's incorporated into the OAuth 2.0 spec. And in this case, in the flow that we're looking at, is being used to try to authenticate the client. In our case, we're not actually using it to do any authentication for us, but it is worthwhile to understand how it works and how it's being used. With HTTP basic authentication, the client includes in a header, and all of this communication should always be over HTTPS, because we're going to be sending a username and password with our request. So in this request, what we do is we include a header for authorization. And the value of that header is basic, the word basic or the keyword basic, followed by the username colon password. And this information here is then base 64 encoded. So we end up with something that looks like authorization basic, and then I have no idea what a proper hash, base 64 encoded value will look like, but something along the lines of this, where we have our authorization header, and then the value for it is basic with the username colon password base 64 encoded into a string. And all of this is passed in a header to the server, and then the server can pull out this part right here. It can see based on this that the authorization, the authentication scheme is supposed to be basic. It can then pull this value out and extract the username and pass out of the value and then use it for authentication. Now, you can see why it's so important that this run over HTTPS. This is being sent in plain text. If you don't protect these requests that have basic authentication with HTTPS, you're essentially sending your username and password over the network where anybody could intercept it and see it. So it's really critical that this always go over HTTPS. And in this flow that we're looking at here, we're going to be sending that information for the client, which is the username, or the client ID in this case is going to be the username. So we're actually replicating this bit of information. We're going to include it both in the body of the request and in our authentication header or authorization header. And then the password in our case for what we're going to be doing is just the empty string, because we don't trust the clients to have a client secret. If you did trust them, this would be the client secret, would be the password down here. But in our case, we can't trust the platforms that our apps are running on somebody else's mobile device. If they took our app, they could easily extract the client secret, so we're not going to be providing one.